In this video, we'll be walking through the proper drain setup for Mabru systems and demonstrating why correct drainage installation is so important for the long-term performance and lifespan of the unit. Proper drainage helps prevent standing water inside the drain pan, which can lead to corrosion, water overflow, and premature system wear over time. Our goal is to help ensure customers get the longest possible lifespan from their installed systems. Nicholas will be demonstrating our recommendations for proper installation. The system shown in this demonstration is a Mabru SC12DC. To begin, we've filled the drain pan with water. Both of the drain fittings we'll be using as examples are facing upward. In this position, no water can properly drain from the unit. You'll see, the drain pan is only about 1/8 of an inch away from overflowing. We'll begin by rotating the rear drain fitting downward. At this moment, the unit is sitting completely flat and level on the surface. We do not recommend this kind of setup. But let's take a look at how much water we're able to drain with the unit in a completely horizontal position. Notice that the drain hose is being held down as flat and low as possible. This is important because if the hose rises upward at any point, it naturally creates a blockage that restricts water flow and prevents proper drainage. The drain hose should always be routed as low as possible to maintain consistent gravity-fed drainage. As you can see, some water has drained from the pan, but the remaining water level is still too high. We've drained as much water as possible with the unit sitting flat. You'll notice the compressor feet are still submerged, and the drain pan is still approximately half full. Proper drainage is not attainable with this kind of setup, even with correct routing of the drain hose. Now let's look at how shimming the unit improves drainage performance while still using the rear drain outlet. All Mabru units include 2 rubber shims like the ones shown here. We are now going to place these shims underneath the unit to slightly pitch the system toward the drain outlet being used. This is a good example of one of our recommended drainage setups. Note that the drain hose is being kept as flat and low as possible. Now there is no standing water underneath the evaporator. From the back side of the unit, the water level has now lowered to just below the evaporator, which is considered an acceptable water level inside the drain pan. Next, we're going to switch from using the rear drain outlet to the front drain outlet so we can take a look at our ideal recommended drainage setup. In a normal installation, you would typically only use one drain outlet. Any drain outlets not being used should remain sealed using a 1/2-inch drain plug. We'll now remove the shims that were pitching the unit toward the rear drain and return the unit to a completely level position. We're also going to move the unit slightly past the edge of the surface so we can rotate the front drain fitting fully downward into a 90-degree angle. A drain fitting pointed straight downward is the most ideal setup for proper drainage. If possible, we recommend opening a hole for the drain so that the drain hose can connect from below. However, even with the fitting pointed down, the unit itself is now sitting flat and level, so water flow has nearly stopped and is still marginally contacting the evaporator. We want to avoid this whenever possible. For this to be an ideal setup, we want to create as much pitch as possible toward the drain outlet being used. Same as the previous recommended drainage example, we'll place the rubber shims underneath the unit, this time from the back side, angling the system downward toward the front drain outlet. Now we are looking at our ideal recommended drainage setup. The unit is shimmed and gravity feeding any condensate in the drain pan towards the drain outlet, and the drain hose is connected from directly below, allowing for the best drainage possible. Now we can see a much stronger flow coming through the drain hose, and there is very little standing water remaining inside the drain pan. Let's break down why these drain angles make such a big difference. We'll rotate the front drain fitting back up to a horizontal position, similar to the earlier rear drain setup, and mimic how the drain hose would naturally route downward into the hull. What commonly happens during installation is that the drain hose develops a slight rise before dropping downward. If the unit itself is not elevated properly, that rise in the hose creates a backup point that traps water inside the drain pan. In some cases, installers can improve this by using a 45-degree fitting to reduce the rise created by the hose routing itself. However, whenever possible, our recommended and preferred drainage method is to use a 90-degree fitting directed straight downward from the drain outlet and drain pan. This allows the drain hose to connect from below the unit and ensures a properly gravity-fed drainage system with the best possible water evacuation from the pan. In this demonstration, we have shown you both our ideal drainage setup and an acceptable alternative setup. Note that a sump pump may be used to assist in proper drainage if needed. Please bear in mind that as you put the mounting brackets on the unit to secure it, do not tighten them in a way that negates the angle you've created with the shims. Avoid installing the unit without using the provided shims to pitch the drain pan towards the drain outlet. And remember, if there are any rises in your drain hose, the unit will not be able to properly drain. Ensuring proper pitch using the provided shims, proper hose routing and security, and unrestricted gravity-fed drainage will help minimize standing water and keep the system operating as intended. For additional installation guidance or technical support, please contact the Mabru support team.